Going to work on the lead code problem, container with most water. So this problem is categorized as a common coding interview question for Amazon, Facebook, and Microsoft. So you're given an integer array. Each value of that array represents the length of a line. So given that values, you need to find the container with the most water. And they've also given this condition that you may not slant the container. So what it means that if two lengths are different, you need to select the minimum length from that and use that to create the container. So yeah, this problem was asked to me during my Amazon coding interview question, but instead of this, what they said was find the largest rectangle in a histogram. So this is a case where you'll be given values where each value represents a bar chart. You need to find the largest rectangle that you can create from it. So yeah, there are a couple of ways to solve it. Most people, I think, they try to solve it using the brute force solution, where they create two for loops, and they try finding the area for each of them. And yeah, and that solution actually works. So I'll just code the solution to show it. So yeah, let's start. So int result equal to 0. Now we create the two for loops to traverse down the entire integer array. So we'll create outer for loop. This will be the starting pointer. We'll create another pointer, which will be the ending pointer. So the way to calculate the area is equal to the product of the length into the breadth. So the length will be the minimum of the heights of the two values that we're selecting. So let's first calculate that. So int, I'll just call it min. So this will be used to calculate the length. The breadth will be the subtraction, so the higher value subtracted by the lower value. So it's going to be like int length, oh sorry, breadth, I think. And then finally the area. So this calculates the area. So every time we calculate the area, we need to compare to see if this is the largest value that can be stored. So for that, we just say result equal to or the result itself. So this way, what we're going to do is we're going to calculate the area, and every time we compare it with the result and ensure that the maximum value is being saved. And yeah, in the end, we just return the result. So yeah, going with the solution again, we are creating two for loops, and we just traverse a combination of all possible combinations that can be calculated for the two integer arrays. We calculate always the minimum value of the length. We calculate the breadth, which is just a subtraction, and then we just multiply it with the area. And yeah, let's try running it. So use cases are passed. We'll try submitting the solution. Okay, yeah, time node exceeded. So this is actually expected. So if you're like interviewing for SD1 role, I think the solution will be accepted. But for SD2 and higher, we are expected to solve it using a linear solution. So yeah, let's calculate what the linear solution could be. So yeah, logically speaking, the largest area will always be, the furthest values. So, if we have, say, here's equal to 1 and here's equal to 8, so this is the largest area that can be calculated. And then what we could do is we can keep decrementing it, the count, based on which of the values is higher. So I'll give an example of that. Here, for example, result equal to 0. Now let's create the two pointers. So int height dot length. So yeah, we're just adding the values. So one of them will be the starting pointer, the one will be the ending pointer of that integer array, and while I so the logic will be similar. So first thing we need to calculate is the length. So the length will always be like the minimum of the two values. So mat.min. So this calculation is similar to what we did before, and we keep comparing the result. So this logic is pretty much similar to what we did before. Now we need to determine how to increment or decrement the counter. So here we know that the largest area will be the one which has the greatest length. So what we'll do is we'll use that to determine how we need to increment the pointers. So if so the starting pointer is smaller than the ending pointer. So the larger area is the one which has the greater length. So we just increment the starting pointer. We say I plus plus. Else, if they're equal, or even if the ending pointer is smaller, we'll just decrement it. So that way we are going to keep decrementing the two pointers until we reach all the way, where I is less than j. That's so we have calculated all possible combinations. So let's try running it. Oh, I think I just used the correct ones. Oh, I forgot to return the result. Just going with the solution. Yeah, everything else looks correct. Yeah, let's try submitting it again. Alright. So yeah, the time complexity will be O of n, where n is the length of the integer array. So it's going to be a linear solution since we are having these two pointers and we keep incrementing and decrementing them. The space complexity will be O of 1, so it'll be constant. Since we're not using any new data structure, everything is happening in place.